Chapter 11, Inventory Management. Inventory is the stock of any item or resource used in an organization. Manufacturing organization or service organization systems, they need something for future use. They are inventory. Manufacturing inventory, raw materials such as wood, steel, plastic, they are raw materials. Using raw materials make something, parts, parts or components, they are also manufacturing inventory. Supplies and working process, unfinished, semi-finished products in process that they are working process. Then finished product. After finish, final product in the store somewhere. Final product or finished product also inventory. Function of inventory, why they needed inventory, maintaining independence of operations. If a company produces multiple types of product, maybe A and B, then schedule is A, B, like this, produce the production schedule. Then if there is not enough inventory of type A, then maybe skip this schedule and then B can start. So the operations can be independent if there is enough inventory. And to meet variation in product demand, if demand is increased, then if not there is inventory, then meet that variation. The flexibility scheduling, the same story. If there is enough inventory, then they can change the schedule. And then provide a safeguard. The same story. This one variation. So if they have enough inventory, such as a safeguard, then like a delivery delay doesn't matter because they have inventory as a safeguard. Then to take advantage of economic purchase order size, if buy one by one, then pay a regular price. But if the company has enough size of inventory space, then the company can buy more, like 1,000, 2,000. Then the company can size discount. Inventory cost, holding cost, holding cost or carrying cost. If there is an inventory, then they have something cost, such as handling cost, insurance cost, security cost, brokerage cost, and so on. And then setup cost. If they produce multiple types of products and then use only one production line, then they change process for each type of product that is set up. Then to change, they need employ workers, then time and so on. So those to make each different product that is cost to make. different products, there is setup cost. Ordering cost when place order, such as shipping cost, that is ordering cost. And shortage cost, if there is no demand but out of stock, no inventory, then we call that opportunity cost because there is demand but there is no inventory, then cannot sell. So there is opportunity to sell, but because there is no stock, cannot sell. So shortage cost is opportunity cost. Inventory system. Inventory system is the same as ordering system. Two set of policies and controls that monitor levels of inventory and determine what levels should be maintained when stock should be replenished and how large orders should be. So inventory system, ordering system determine the level when how many inventory level left, then place order. So we call that we order level, inventory level. So determine the maintain that inventory level. And then when place order, determine how many uh, item should order. So there are two types of inventory system, ordering system, or ordering system. Single period inventory system, multi-period inventory system. Single period inventory system, one-time purchasing decision. To place order, decide order size, and then place that order size, then forget it. The next time, decide again and forget it, and again, decide again, and so on. So if they use a single period in inventory system, then the order size not to be uh, not be reordered. That is single period inventory system. Multi-period inventory system. If decide order size, then order this time, place order this time that amount, and then next time the same amount, order again and again. There are two types of multi-period inventory system. First one is fixed order quantity model. Decide order quantity and then order that amount again and again, use that again and again. Other name of this model is the economic order quantity model, EOQ model. Then because we decide order quantity, so this is Q model. And the other one is fixed time period models. Decide time when place order, like every 10 days or every 15 days. So fix the term, the period. So fixed time period model. Other name is the periodic system, periodic review system, fixed order interval system. Because the fixed period, so this is P model. And fixed order quantity model is event triggered model. And this one is time triggered model. I will tell why fixed order quantity model is event triggered model and why fixed time period model is time triggered model later. Fixed order quantity model. Using this model, we can determine point R, reorder point. When inventory level hit that point, reorder point, it's like a maintain level. So we can decide that point R, reorder point, and size of order quantity Q. Basic model assumptions. Demand for product is constant and uniform. If demand is constant and uniform, then if order Q, amount of Q, then inventory level here, and then if demand is constant and uniform, then this inventory level line is straight line. And lead time is constant. Lead time is the time between place order and receive, kind of delivery time. That delivery time, lead time, whenever place order, the same. And then price per unit of product is constant. Today's price per unit, and next time the same. Inventory holding cost is based on average inventory. During this period, from inventory level Q to 0, average inventory is about here, that is Q divided by 2. So during this period, because this inventory level line is straight when demand is constant, then average demand is Q divided by 2. And then ordering and setup costs are constant every time the same whenever place order. And then all demand for the product will be satisfied. So order Q and then receive Q. So initial inventory level is Q, then 0 here. So during this period or term, all order consumed completely at this point. So they are assumptions of basic model. Here, when receive the order Q, then inventory level is Q, then demand, there is demand, and then inventory level decrease, then hit this point. Because of lead time, place order earlier than zero inventory. So lead time, the day of lead time of lead time, place order earlier. So when this inventory level hit this point, that is the reorder point. This Q model is event triggered model. So event is this point R. So when this inventory level hit, so that is the event, hit this point, reorder point, then place order. So this Q model is event. Event is hitting this point, triggered model. Okay, total cost. equals annual cost, by the way. Annual total cost equals annual purchase cost. Uppercase D, that is annual demand. Then C is cost per unit. So this is annual purchase cost. And annual ordering cost, D divided by Q, if annual demand D equals 1,000, then if we decide the Q as 100, then D divided by Q equals 1,000 divided by 100 equals 10. So if order size is Q and annual demand is D, 100 and 1,000. To satisfy this annual demand, and if order size is 100, place order 10 times. So uppercase D, annual demand divided by order size Q is how many place order. So this is how many place order and then order cost. So annual ordering cost. Annual holding cost Q divided by 2. This one is average inventory level. So average inventory level times holding cost per unit per year. So this is annual holding cost. If increase order size, then total cost decrease and hit certain point and then increase again. So here, if order quantity is here, then this total cost slope is negative, negative, negative. But here on this point, the lowest total cost point, slope is 0. So using derivative about Q, then equals 0 because slope is 0, then we can get this order size, order quantity. And then on this point, increase order quantity, then ordering cost decrease, but holding cost increase. At this point, on this point, optimal order quantity, then holding cost and ordering cost the same. And then reorder point R equals daily demand times lead time. Example, annual demand is 2,000, holding cost $2.50 per unit per year. Cost per unit is $15. Ordering cost equals $10 per order. And lead time is 7 days. Order quantity Q, EO OQ or optimal order quantity. Using that formula, square root of 2D, uppercase D, this one is annual demand times order cost divided by H holding cost. So 2 times 2000 times 10 order cost divided by 2.5 holding cost equals 126.49. Always round up, even after decimal point like the point one, still uh, round up. Then reorder point, daily demand or average demand. This example doesn't say about how many days. So use 365 days of one a year. But if when you take a test or a quiz, then mention how many days like this company produced 200 days. The store open 250 days like that. If how many days per year is mentioned or given, then use the number to get daily demand or average demand. Anyway, for example, this example doesn't say about that, so use 365 days to get daily demand and times lead time 7 equals 5.4794 times 7 equals 38.36. So round up, always round up 39. Total cost, annual demand times cost per unit. So this is annual purchasing cost. And then order cost, how many place order? 2000 annual demand divided by order quantity times order cost. So this is annual ordering cost plus annual holding cost, average demand, average inventory level, Q divided by 2 times holding cost per unit, 5. So this is annual holding cost, 30,000 plus 157.48 plus 158.75. If I used to get total cost using this one, not rounded up amount, then this annual ordering cost and annual holding cost should be the same, because if it is optimal, then this point annual holding and annual ordering cost should be the same. But I used rounded up this amount, so a little bit different. Fix it. Order quantity models with safety stock model, because in real world demand is not constant, vary from day to day. So sometimes there is stock when received the order, but sometimes out of stock. So this is kind of a safety stock, safeguard. So we need safety stock. So we call this safety stock model. Safety stock model or the Bayesian model, order quantity is the same. Only difference is reorder point because there is the Bayesian model reorder point plus safety stock. So in this safety stock model, reorder point equals Bayesian models reorder point daily demand times lead time plus safety stock. Safety stock equals Z score times standard deviation during lead time. G is about service ability. I will tell about that later. Then this one, standard deviation during lead time equals square root of and sum of from 1 to L, the lead time, standard deviation square, that is variance. Example, daily demand equals 60 units. Annual holding cost is 50 cents. The desired service probability equals 0.9, P equals 0.95. This desired service probability is, for example, if you go a store, then 100 times. Then if you buy 95 times whatever you want, then 95%. The store's service probability or service ability is 95%. If that store want to increase the service probability or ability, the store need to increase inventory level. So anyway, this one service probability, using this service probability, we can get Z score. The cost of placing the order equals $10. Standard deviation 7 units. This one, standard deviation is about daily demand. And lead time equals 6 days. Okay. Basic model or safety stock model, the order quantity is the same. So using the same formula, 2ds divided by h and square root. So 2 times this uppercase D is annual demand, but daily demand is given. So convert this daily demand to annual demand. The same, this one doesn't say about how many days per year. So using 365 to get annual demand times order cost equal and divided by 0.5 annual holding cost per unit square root equals square root of 876,000 and equals approximately rounded up 936 units. And for the reorder point, we need standard deviation during lead time equals square root of and sum of 1 to L standard deviation square. So standard deviation 7 square variance add L many. So 1, 2, 3, 4, 5, 6. 6 because lead time is 6. So this one standard deviation during lead time equals L lead time times standard deviation square square root. So this is standard deviation during lead time. And we need z score is about this 0.95. We can find z score from this normal distribution chart. This chart is in your lecture notes. Sometimes the student ask me when they taking test, where is the chart? Chart is in lecture notes, and then that lecture notes on Moodle. Okay, 95.95. We cannot find the exact 0.95, but it is between 0.945 and 0.950. 0.95 is closer to this one between these two. So take this one. Then Z score is 1.65. So plug in 1.65 for Z times 71.15. And daily demand is not given. So 60 times lead time 6, and so on. And by calculation, we can get this reorder point. Next one is a fixed time period model. This one is in the next class. Before finish this one, I want you to practice yourself this practice problem. Before our next class, please practice yourself this question, this practice problem, not B, only A. Next class, we will go over this, and then the fixed time or period model. Next class. Okay, that's all. See you Wednesday.